Okay, so we're starting with the reference sheets. Your first slide should look like just this part up here. We're talking about transformations. Transformations are huge. Not just that you can move a graph around, but that you understand conceptually, overall, big picture, what is happening. Okay? It's not, I can plug numbers in and put it on a T-chart and plot something. Great, a monkey can do that. That's not what this is. Right? It's understanding what is happening to the function when different numbers and signs and whatever are being applied. Okay, so we have two main types of transformations. The first one is rigid transformations. Okay, that's a change in position or orientation of a function, and those are mainly translations and reflections. Okay, you move it left or right, up or down, flip it over. That's what's happening there. Then we have non-rigid transformations. They distort the shape of the function by changing its size. Those are your dilations. You shrink it or enlarge it. Okay. Then we're going to review our rules because you start learning these in Algebra 1 for sure. And then this is a big, huge part of what Algebra 2 is, so none of this stuff should be new for sure. So if you go on to the next slide, it should be your translations. I put each little piece on a separate slide. I couldn't decide if that was better or cram them all in one and it'd be tiny, but... So if I look at this, the example here is a quadratic, right? We just have a parabola, but it could be any function. And you either shift it straight up or straight down. That's what this looks like. So if whatever my function is, doesn't have to be x squared, whatever the function is, if I'm going to shift it down, then I subtract a value. If I'm going to shift it up, I add a value. Okay? We're going to use A, B, C, and D for our translations. You might have used H and K and A and B, other letters. It doesn't matter what the letters are. What it matters is where they are and what they're doing. I mean, because the letter could be anything. Just there's something, being added or subtracted afterwards. What this means is, after you have put your number through the little function machine. If you think about functions as function machines, you have an X, you put it in a little function machine, and then it spits it out on the other side, and that's your Y, right? So after I've done my x squared or whatever it is, then I add or subtract, and that's what moves it up or down. If I'm going to move it left or right, that's horizontal, and that's going to affect x. So that means it has to be done before you actually do the function part of it, before the squaring or square root or whatever. And x lies. Like that, y makes sense. Down is negative, up is positive, but x is a liar. So this is f of x. To go left, it would be plus c, and to go right, it would be minus c, because x lies. Everything's backwards with x. That's what's going to move it left or right. That means I add or subtract, again, before I square it, square root, cube it, whatever's happening. Okay, we good? Sound familiar? All right, let's move on to reflections. So let's talk about reflections in general, like what you learn in geometry before geometry, and geometric stuff you do in like middle school. If I have a point right here, let's say that this point is x, y. I'm just talking about that one point. And I'm going to reflect that point in the x-axis so it ends up down here. What does not change? X. And what happens to y? It becomes negative, okay? You change the sign. That's all that happens. If you reflect in the x-axis, you change the sign on y. When we're talking about functions, y is just f of x. So negative f of x is what is going to reflect it in the x-axis. That means the negative sign comes after you square it, square root, absolute value, whatever. It's on the outside, so it's affecting y. Okay? If I have a point here, x, y, I reflect it in the y-axis, then my y value stays the same, and I change the sign on x. If you ever forget that, all you have to do is put one little point, reflect it, and think about what changes, just like I just did. It doesn't even have to have a picture that goes with it. So if I reflect it in the y-axis, I change the sign on x, so that means the negative has to be inside of whatever the function is, not outside. Any questions at this point? All sounds familiar, right? Knocking the cobwebs off? Okay. All right, let's look at dilations then. To compress or stretch, so a vertical compression or stretch. So I'm either stretching it up or I'm squishing it down. So it's happening vertically. Vertically always means that you're dealing with y. So you're going to multiply something times y, something after you have taken the square root, or whatever. If that number, a, the absolute value of the number, because the sign does something else, if it is between 0 and 1, it's a compression. So if I have 1/2 out there, or 2/3, but not just if it's a fraction, because if I have 3 halves, that's more than 1. So don't let the fractions trick you. And then a stretch, it's still just a times f of x, but this is when the absolute value of a is greater than 1. So if it's a 2, a 4, a 3 halves, something like that. So for vertical, function will compress or stretch vertically by a factor of the absolute value of a. Okay. Then horizontal stretches or compressions. I'm either squeezing it together or stretching it apart. Remember, x is a liar. And it's going to have, you have to multiply before you actually do the function part of it. So this would be f of b times x. That it's the same for a stretch or a compression. What makes the difference is the value of b. Since x is a liar, if it's a compression, the absolute value of b is greater than 1. So it'd be like 4x or 5x. Seems like it should get bigger, but it gets smaller. And then for the stretch, the absolute value of b is between 0 and 1. And if it is 1, then nothing changes, so it's nothing. So the function will compress or stretch horizontally by a factor of the absolute value of 1 over b. So if this is a 4x, it gets compressed by a factor of 1/4. What questions do we have? Okie dokie. Then your next slide is just an overall kind of reference sheet for the rules. I did, however, on the generic one, I left off a parenthesis, so you're going to have to fix my mistake here. I didn't close this parenthesis. But that's basically where the A, B, C, and D goes, if you're doing them all. And this says the same thing that we just wrote over there, then the words, and just a little example of what's happening with your variables. But just another way to look at it if you need a reference sheet, okay? What questions we got? We good? All right. Remember, you can actually go back and look at your notes. I highly encourage it. And even though if you're having to write on your phone because it's little, you can look at it big on your computer to go back and reference things. Okay, so then let's move on to the other set. And before we do that, we're going to do a little other activity that I'm not going to record. Put that down. We'll look at how we're going to identify these. So we're going to, the directions say, given each function, we're going to identify both the parent function and the transformation. So when we identify the parent function, there are 3 things that we write down. First of all, it's the name of it. So in number 1, what's the name of that parent function? Cubic. Very good. So it's a cubic. The second thing we write down is the equation. So it's f of x equals x cubed. That's what it looks like as the parent function. And then the third thing we do is sketch a little picture. This is hugely important. So everybody show me, what does a cubic look like? Show me, everybody. Waiting on everybody. Awesome. Okay, so we got a cubic, so we're going to sketch this. It's not a graph, it's a sketch. If you start having trouble graphing and you come to me for help, the first thing I'm going to look for is these 3 things. And if you don't have it, I'm going to be like, that's why you don't know what you're doing. Okay? Just trust me, it's going to make a difference. I don't make you do stuff just for the sake of doing it. All right, so then we're going to look at, we have to list the transformations. So if you're consistent, go left to right, and I always kind of make a little list first of like how many I have. The only thing that's happening is this -4, right? And what's that -4 going to do? Shift it down. So we're going to go down 4. That's it. Okay. All right, so then number 2, what's this one? What's this parent function called? Square root. Okay, and that's f of x equals the square root of x. then show me. Become a square root. Embrace the square root. Make sure you're going the right way. You're going the wrong way. Yeah. Okay. Second diva. Yes, so it goes like this. All right. So then I'm going to list, make a little like bullet list. I have a 2 here. I have a negative sign. And I have a -1. So there's 3 things. If you do that, then hopefully you won't forget one of them if you're doing some of them. And don't jump around. Go from left to right. The more consistent you are, the better. So I'm multiplying by a number, which means that's either a stretch or a compression. So I need to decide, first of all, if it's vertical or horizontal. Is it being multiplied before or after the function happens? After. It's after I've taken the square root. So it affects y. If it affects y, it is vertical. And would this be a stretch or a compression? Stretch. Good, because it's bigger than 1. So it's a vertical stretch by 2. Then I have that negative sign. I know that means a reflection. So, okay, I know it's a reflection. I can write that down. But I got to decide, is it an x or y axis? So does the negative affect the x or the y? Which does it affect? It affects the x because it happens before you take the square root. It's on the inside of the function part. Does that make sense? It affects x, which means we reflect in, which one? Y. Reflect in the y-axis. And then that -1, what does that do? Moves it to the right one. Good, because x lies. What questions do you have? We all good? All right. So I don't know if number 3 is on the next slide or if it's on the same slide, but let's go to number 3. So what's the name of this parent function? Quadratic. Quadratic. F of x equals x squared. And if you don't know what a quadratic looks like by now, you've been living under a rock. Okay, so I'm going to make my little bullet list here. I've got a negative, I've got a 1/4, and I've got a 6 that I got to deal with. So that negative, does it affect x or y? Y, because it happens after we square it. So I know it's a reflection, and if it affects y, it's a reflection in x-axis. X-axis. I can't, oh my gosh. X-axis. All right, that 1/4, it's being multiplied, so I know it's either a stretch or a compression. I have to decide if it's vertical or horizontal. Does it affect x or y? X, which means that x lies, so I do know it's horizontal, but is it a stretch or a compression? Stretch, because it lies, right? It looks like it should be a compression, but it's a stretch by the reciprocal, which is 4. And then what does the 6 do? Moves up 6. Okay. Any questions at this point? Good. All right, what's number 4 called? Absolute value. So that is f of x equals the absolute value of x. Show me your best absolute value. The YMCA, right? Now be a nice absolute value. Okay, good. Good job. All right, that's your V for value. All right, so I've got a 3, I've got a 5, I've got a 2. The 3 is being multiplied. Is it going to be a horizontal or vertical? Horizontal. It affects x because it happens before the absolute value. Does that make sense? It's like on the inside. So I know it's horizontal. Is it a stretch or compression? Compression. Good, because x lies, so it's a horizontal compression by 1/3. What does the 5 do? Left 5. Good. And the 2 goes down 2. Everybody good? Any questions? Okay. I don't remember if I left 5 and 6 on there, but we're going to skip them. So I didn't. Okay. And so hopefully the next slide is 7. If not, just skip the next slide and get to 7. Because we don't need to do every single one of these, so we're not going to. But oops. All right. So 7. What is this one called? Cube roots. Very good. Cube root. So that's f of x equals the cube root of x. Then show me your best cube root. Yeah, it's a lot more like walk like an Egyptian like this. Kinda, yeah. All right. So cube root looks like this. Then I have a negative, a 4, a 1, and a 2. So I'm going to give you a second to figure out what those are on your own. Okay, so this negative v, what does the negative do for me? V. Reflects in what? In which one? X-axis, yes. Good. Reflect in the x-axis. Very good, because it happens after you do the little function part. Okay, so then we have the 4. Kayleen, what does the 4 do for me? Very good. Vertical stretch by 4. And then the 1, what does the 1 do, Daisy? Left 1. And Swazi, what does the 2 do? It happens after this, so it's going to affect y. So this is my up or down. Up 2. Very good. All right. Any questions at all? We good? Okay. You missed a quiz, sweetheart, so if you can come in during math time. You are? Okay. Awesome. All right, so let's look at number 8. Do you know what this weird looking thing is? Probably not, and I don't expect you to, okay? So this, mine always kind of looks like a blob up here. I think it's clearer on yours, but it kind of looks like this, like a double-walled bracket, okay? That's what it's supposed to be, but mine just looks weird. But this is called a signum function. It can also be called a sign function, S-I-G-N, but we don't usually call it that because there's also an S-I-N-E function, and that can get very confusing. So signum is more what you're going to be called. But what it looks like and what it does and how you handle that to actually find values is completely irrelevant, right? Can you still tell me what the transformations are? Yeah. What does the 5 do? Moves it to the right 5. What does the 1 do? Moves it down 1, right? So maybe signum means you graph a picture of a monkey. Then you would just take the monkey, move it to the right 5 and down 1. That's all that matters, okay? So even though on these I was making you write all this, it was kind of irrelevant for what we were actually doing with this, but you're going to need to do this for everything we graph, so trust me, okay? We good? Any questions at all? Okay, I think I did leave 9 and 10 on there, but we're not going to do them. I don't feel like we need to. So the next one I want to go to, which I think is what I did, is number 13. Is that the next one? Okay, go to number 13. There's usually way too many examples. We could do examples all day long. Okay, so this time we get a graph. We get a graph of the parent function. So the picture in number 13, what is that? It is a cubic. So this is a cubic, and it is f of x equals x cubed. Then we are going to, they're going to tell us what the transformations are, and we have to write the equation. Okay? So it says I want to vertically stretch it by a factor of 4 and translate 1 unit up. So this, since that's f of x, we'll call our next one g of x, because it can't also be f of x. So I'm going to take a cubic, I'm going to stretch it by a factor of 4. So if it's a vertical stretch, that means it happens after I cube things, so it's on the outside. And translate up 1, that also affects y. So this would just be 4x cubed plus 1. You agree with that? Yes, ma'am. Like this, it would be fine. It's the same. It's just not necessary, so you probably wouldn't see it that way, but it wouldn't be wrong. And I'm 99.9% sure that Delta Math wouldn't count it wrong either. Because usually if you have extra stuff, as long as it's not wrong, it's okay. Okay. Then C, so we're going to call this one h of x. We're going to vertically compress it by a factor of 1/3 and translate 5 units left. So you try that one. Let me give you a second to get that one done. Okay, so vertically compressed means we're affecting y, so it happens after the cubing. Translating it to the left happens before you cube it. So I know that this 1/3 will be on the outside. 5 units left, x lies, so it has to be x plus 5 cubed. Okay. Do we agree with that one? Any questions at all? All right, so then let's do number 14. What is this parent function called? Cube root. Good. Cube root. So this is f of x equals cube root of x. So we're going to reflect in the y-axis, which means the sign has to affect x. So it has to happen before the cube root. And I'm going to translate it 4 units right, which means it has to happen before the cube root as well. So if this is g of x, then I know that I'm going to have x going 4 units right, so it's going to be minus 4, and then negative right here. Okay, there has to be parentheses there because the negative's always factored out. All that happens underneath the cube root. This would be a reflection in y, and this is moving 4 units to the right. Okay, we good? What questions we got? All right, you do C. We'll call it h of x. Read it. Write yourself an equation. Okay, so horizontally compressed, that affects x, so that has to be under the cube root by a factor of 1/2, and x lies, so I'd actually have to multiply by 2. So I'm going to have a 2x, and then translate 5 units down. That happens after the cube root, so I can go ahead and put my cube root on here, and then minus 5 on the outside. Careful that you don't get sloppy with your roots and that like you can't tell if the 5's underneath or not. But that's what that one should look like. Everybody okay with that? Any questions at all? All right, we got one more. number 15. So 15 says, if this is our function, 2 times x minus 5 squared plus 3, if that function is reflected across the y-axis, then translated right 6 units and down 2 units, I want the new function. So instead of starting with a parent function, I'm starting with a non-parent function, like a cousin function maybe. And if I'm going to reflect in the y-axis, it has to be on the inside of the x, right? So that means I'd have to have a negative, and then it's going to be x plus or minus something. All right, so right now I'm at x minus 5, which means I'm not here. I have moved which direction? What is this one? To the right. So I'm over here at 5, right? And so I want to translate it right 6 more units. So what does this number become? 11. So now this is minus 11, right? And close that. And then I'm going to square that, right? You see how that negative has to work there? Because it has to be factored out of the translation. And then I want it to go down 2 units. Well, I'm up at 3. I go down 2. Where do I end up? At 1. And then this 2 out here, nothing changed with that. So that's it. So sometimes you might have to manipulate something that's already been manipulated, but it's the same concept. Okay. We good? What questions do you have? All righty. That's it then.